I will hear you, Paige. Hello and welcome to Slooh, where you can learn to explore space. I'm Paul Cox, and you're joining Slooh for a very special event today. A stadium-sized lump of primordial space rock, as old as the solar system itself, is whizzing between the Earth and the Moon over the next 24 hours. Now, this particular space rock, classified as a near-Earth asteroid, and rather imaginatively named 2010 WC9, was first discovered back in November 2010. And astronomers, including Slooh members, actually were able to monitor it for about 10 days before it got too faint to observe. Now, the problem was, with so few observations, its orbit couldn't be fully determined. So WC9 joined the hundreds of near-Earth asteroids that are discovered at great cost, but then get lost because no one has actually made sufficient follow-up observations to track it. But last Tuesday, the 8th of May, WC9 was rediscovered, what's called a recovery in astronomy circles. And over the last 7 days or so, astronomers around the globe, once again, including Slooh members, have focused their telescopes on it. And we now know actually exactly where it's going to be and where it's going to be for the next 300 years. Now, Slooh members have already been watching live streams of WC9 from Slooh's telescopes this evening, and that's what we're going to enjoy a little bit later on during the show. And don't forget, members can continue to watch WC9 missions after the show too. Now then, if you're new to Slooh, make sure you watch the show at slooh.com, where you'll be able to switch between all of our live telescope views, and you'll even be able to snap your own images throughout the entire event. And obviously make sure you post your captured images to your social channels to alert your friends to this event. Why not stick in a little tabloid headline as well, just to get them going. Anyway, coming up, what have we got? So we've got lined up for you over the next hour while we watch WC9 whiz through the sky. We've got loads of exciting stuff, and I'm going to be joined by Slooh astronomer Dr. Paige Godfrey, and we'll learn a little bit more about the telescopes we're using for tonight's event, the same telescopes actually that Slooh members get to control every night. And we'll also be learning a lot more about this pesky space rock as it makes an all too close flyby of Earth. Now, Paige will also be telling us a little bit later about the risk of asteroids, the risk that they pose to life. We can discuss that, maybe a little bit of history, and how Slooh members got involved as well in tracking asteroids. But anyway, listen, if you've got any questions for me or Paige during the show, just post them to Slooh's discussion boards on the website or our social channels using @Slooh. Now then, before we're joined by Dr. Paige Godfrey and take a look at our live feeds tonight, we want to ask you to support Slooh. If you're here, you're probably interested in learning about space and astronomy. And if you are, please consider joining Slooh as either an apprentice or an astronomer member to support our mission to teach the world to explore space. Now, you are not only supporting Slooh in that, but you get to watch live views of the sun, the moon, the planets, galaxies, nebulae, star clusters, constellations, supernovae, and just about every other celestial object in the night skies through Slooh's online robotic telescopes that actually you can control from the comfort of your armchair. How cool is that? And as a member, you can also follow our various courses and live casts about astronomy. Just this weekend, actually, we watched some stunning image streams of an entire day on Jupiter. And last night, we captured the oldest star known. It's as old as the universe, live in the telescopes during last night's live cast about the mythology of the constellation of Libra with Slooh's storyteller Helen Avery. So join Slooh's global community today, where we'll all learn to explore space together. So now then, let's get down to our main event, shall we, to learn about this chunk of space rock hurtling past Earth And to help us do that, I'm delighted to welcome Slooh Astronomer and Director of Research and Education, Dr. Paige Godfrey. Good evening, Paige. Welcome to this very special event, this celestial close shave we're witnessing tonight.
Good evening, Paul. Happy to be here. Good evening, everybody that's listening and watching safely from the comfort of your home.
Exactly. Yes. So,
Paul,
Paige,
before we learn
yeah.
more about this asteroid, can you tell us about the live feeds that we're going to be watching from tonight?
Ooh, yes. Well, Slooh has two observatories. We're only going to be using one of them tonight. We've got our observatory for the southern hemisphere skies in Chile, but tonight we're using the Canary Islands. And tomorrow night, actually, this particular chunk of space rock is only going to be visible from the southern hemisphere. So the Chile observatory is going to be perfectly placed for that tomorrow. But tonight we're using the Canary Islands.
So we're just using one tonight. Tomorrow night we'll be watching from Chile. How's the weather looking?
Oh, well, we can see here, this is our special low light special camera, all sky camera, which looks at the entire sky. And then we can see that really bright object there just below center. That's actually the gas giant Jupiter. And we can see a few clouds there hovering around, but it's looking pretty good, Paige. I mean, you can actually see
Good.
there just on the left-hand side of the image there, what looks like cloud. There is a bit of cloud there, but actually the main mass of that is the Milky Way. And we know that if we can see the Milky Way, we've got some pretty good conditions up on the mountain.
So we have 6 telescopes up on that mountain in the Canary Islands. Are we using all 6 tonight for this?
Yes, we are. And, you know, that particular, our Canary Islands Observatory is actually located in, would you believe, the Canary Islands. And that's a group of islands about 300 miles off the west coast of Africa in the Atlantic. And it's actually named the Observatory del Teide. And it's operated by our partners, the Institute of Astrophysics of the Canary Islands, one of the premier astronomical organizations in the world. And not unsurprising, really, given that they have one of the best observing sites in the world. In fact, did you know, Paige, the largest optical telescope is based in the Canary Islands, not in the Atacama Desert or anywhere else that most people think up on Hawaii. But our 6 telescopes, we've got 6 of them up there, but we're going to be using 5 of the nighttime telescopes tracking WC9 tonight. The 6th telescope is our very special solar telescope that operates during the day and gives us unrivaled live video streams of our local star, the sun. And by the way, if any new members join tonight, then make sure you check the solar scope out tomorrow, because we've been tracking some incredibly active solar regions, which has been pretty cool, really. Well, I guess pretty hot, actually. But anyway, the 5 nighttime telescopes, the same ones that Slooh members use every night to capture just about every type of celestial object, will give us some of these great views of the asteroid tonight. And what we're looking at here, our first image, is our half-meter telescope. This is our premier system. It's an enormous telescope by any means, equipped with cooled CCD cameras, scientific grade CCD cameras, and all sorts of things. So that's only one of the 5 views that we're going to have tonight, Paige.
So is it going to be easy for the viewers to see this on their own, or are we going to have to point it out to them? Will they be able to tell? Like, how will you be able to tell what the asteroid looks like in these views?
Okay, it's going to be a little bit different in each view. And don't forget, if viewers are watching at slooh.com, they can snap their own images and save them for later and look at them in more detail. Now, this one, the half-meter telescope, we're going to watch a static star field. So all of those white dots there that we can see at the moment are just stars in the background. What we're going to see in this view is a small, in fact, I can already see it. It's just below the top of the image, near the center, widthwise, and you'll see there's one little object there that isn't a pinpoint star. It's a tiny line. Now, as we gather and stream more and more images, that little line, that tiny little speck, is 2010 WC9. We're watching it live, and it's going to cross over this hour the entire field of view page. So that's going to be a pretty good view to look at. And you know me, I love time lapses and stuff like that. So we'll create some time lapses a little bit later on there. We can see it a little bit better. So in three of our telescopes, so we've got our Canary 1.5 meter telescope, we've got our Canary 2 telescopes, we've got our Canary 3 telescopes. All of those are going to have this fixed star field. But our Canary 4 solar system telescope is optimized for the planets and small objects like this. This is going to give us close-up views. And this time, we're going to be tracking the asteroid as it moves across the background stars. So in that particular view, we'll see it very, very clearly. And sometimes we may even see, so there we've got the wide field view. I'm just looking at this really, really closely. I can't see it in that one yet, but once again, it's going to come in probably from the top of that image. That image might be a little bit cut off. There we got the ultra wide field. Now, this is an incredibly wide field of view. So this one is, let's have a look, see if we can see it in there. I think this one is going to be easier to see. It's got such a wide field of view. This is going to be really quite a small line in this particular view. So what viewers need to keep their eyes open for in this particular view is a line, a very small line that moves over the course of minutes, but a lot easier to see in our Canary 1.5 meter and our other one. And this is a deep sky. This is very, very similar to our ultra wide field telescope. And this is our largest field of view. Now, I did see it in there, so I don't really poke my nose right into my camera at the moment. But I did, I have to get up close to be able to see this. It's quite small on my screen. So I did see it in there. So viewers may have better luck. They're watching at Slooh.com to snap that image, and then they can look at it full resolution on their monitor. But if we take a quick look actually at our solar system telescope, if we've got that Canary 4, if we can do that, we will see a different view. So we'll wait for that to come up page anyway. So and we will see a very different.
See this?
Sorry.
Right. Can people go outside and see this? I mean, are we able to see this with the naked eye?
There you go. There is our Canary 4 solar system telescope. This is giving us a far, far more magnified view. And what you can see there just on the left is two little lines. And what's happening here is to take images, to capture very faint objects like this, we have to take very long exposures. So that's actually how far that asteroid moves during exposure. And then what we do is we start adding exposure after exposure. So in this one, we're seeing two lines as it's moving through this field of view. So that's going to be pretty cool. So, sorry, Paige, what were you asking before that popped up on the screen? You know me, I get a bit excited when I see a new image.
If people can go outside and see this, can we look up and see it with the naked eye?
Unfortunately not. Now, tonight it's at what we call apparent magnitude 14. And it is getting brighter and brighter as it gets closer and closer to Earth. But even at its very closest, it's only going to reach magnitude 11, and that's even too faint to spot with a good pair of binoculars, let alone the naked eye. So unfortunately not. So this is a telescope-only view, but why do you need to go outside when you can use telescopes like Slooh's at a world-class observatory site? Anyway, listen, Paige, it's probably time for us to learn a little bit more about this Near-Earth Asteroid 2010 WC9. Can we just call it WC9 now?
Yes.
We need to find out, we need to discover what it is, where it is, and whether it poses actually any danger to Earth. So first of all, let me have a look. Got some questions for you here. So, okay, the first one is a real basic one, Paige, that somebody was asking, I still remember was asking in the discussion boards a little bit earlier. Why is it called 2010 WC9? Who came up with that unimaginative name, and what does it mean?
Well, so despite some of the most common names that we show on Slooh.com, actually, everything always has a weird, unimaginative designation, is what we call it. And so it's based on the telescope that imaged the object for the first time, sometimes a year, sometimes the RAN deck if it's a star. And so those names are always very long and boring and unimaginative. Sometimes most popular objects get an extra fun name, which is what we tend to use on Slooh.com because they're way more interesting and easier to remember. But could you imagine a room of astronomers talking about, the Bull Nebula and the Crab Nebula? Like we use the actual
Yeah.
designation in the conversation for the most part. But this one in particular, I mean, the 2010 came from the year it was discovered. So it was discovered
Mm.
on November 30th, 2010 in Arizona from the Catalina Sky Survey. And then it was actually monitored for a full month before it was lost. But I'm not sure where the WC9 comes from. Paul, do you know what that's for?
Hmm. I do. I was hoping you were going to know about it, but it's a bit tricky. It is a little bit tricky. But let me take a quick look. So what it is, the W is what's called a half month. All right. So the whole year is split up into these 2 week period. Look, there it is again. We've got it showing up. It's beautiful actually in this tight up, close zoomed in view of the solar system telescope. So great, isn't it? So anyway, the W, the whole year is split up into fortnight periods, 2 week periods, and that's what the W stands for. So we know that this particular object was discovered between November 16th and 30th. Um, so actually, we've got one. There's a little line. I've just been told in my ear that we've got a little line, if you can see, just coming from Page's name tag there. That's not actually the asteroid. That's a satellite, an artificial satellite, probably a communications satellite, whizzing through our field of view um, as we're watching for our smaller little line right up at the top of that. So don't forget in those ones. That's a cool view. I do like the solar system view tonight. That's the one actually, Page, that we saw, one of the best views of Jupiter that I have ever seen in any Slooh telescope on. I think it was Saturday night. But anyway, so we know that the W stands for that particular 2 week period. The C is really, it says it's the third object that was discovered, but this is where it gets tricky because the 9 is how many times it cycles through all the letters. So really the 9 suffix indicates 9 completed cycles, so it's 9 cycles times 25 letters, which is 225. But while C is the third position in that current cycle, it turns out that it's the 234th minor planet discovered in that particular 2 week period. Now, I only learned that
Jeez.
tonight because I looked that up, and it took me a while to understand it, and I'm sure I didn't explain it very well because it is, quite complicated.
Yeah.
But anyway, so we there we go. There's the name. The important thing is that we know it's discovered in 2010. But what are we actually looking at here, Paige? We can see it as this tiny white dot, which is moving so fast in the sky that it's actually moving during our long exposure.
Mhm.
But how big is this thing, and how fast is it really going?
So this asteroid is about 120 meters in size, and it's moving pretty fast at 28,700 miles per hour, which is about
Ooh,
12.7 kilometers per second. And that's how fast it'll be moving at its closest approach tomorrow. So
oh, okay.
the reason we're seeing this object like move across the background. So this is something that we teach a lot when we talk about spotting Pluto and how come you see Pluto moving against the background stars. The background stars are so far away that even though they are moving in space, they don't appear to be moving on the time scales that we're watching them. And then relative to the objects that are much closer to us, like Pluto, or for example, this asteroid, which you can see moving greatly compared to a much more distant object. So, one of the examples I like to give is if you have two cars moving at the same speed, even, but one is really, really close to you and one is miles away. And you'll see the one close to you moving much more drastically than the one that's further away. So that's essentially the kind of thing that's happening here. So this
Okay.
asteroid is about a little over 100 meters. It's moving nearly 30,000 miles per hour. And its closest approach is going to be tomorrow night on the 15th at 6:05 p.m. Eastern. In UTC, that's 22:05. I wrote that
Yeah.
down so I didn't say it wrong. But its closest approach is just a little over half of a lunar distance. So the moon away from Earth, the distance between the moon and Earth we call one lunar distance, and that's about 240,000 miles. This is going to be at about 0.53 lunar distances, so it's going to be in between the moon and the Earth, and it's just roughly around about 126,000 miles away from us.
Okay. Okay. Now you said it's close approach. Look at that. So
Yeah.
here we've got page. We've got
Oh, there
the
it is. Yeah.
combination now of three images. So these are three long exposures stacked on top of each other with
Hmm.
processed with Slooh's patented technology and then streamed out to viewers and the telescope pages and stuff at slooh.com. But you said there that it's actually making its closest approach tomorrow night. And in fact, the images that we're getting tonight, if you took that same field of view, even of our very large field of view telescopes, tonight we're just seeing it. There we go, as a time of line. Tomorrow night, at closest approach, its apparent speed is so fast that it would cross the entire field of view during a single 60-second exposure. So people might be asking, Paige, why we're not actually doing our show tomorrow night rather than tonight. And part of that is where it's going. At the moment, it's in constellation of Hercules, isn't it? And it's heading south at this incredibly fast speed. So tomorrow night, we can't see it from the Canary Islands at all. And actually, it's so far south that you've got to be really at a low latitude before you can see this. I mean, it's very, very close actually to the southern celestial pole. So if viewers are wondering why we're doing it tonight, we actually stand a far, far better chance of seeing it tonight than we do tomorrow night. But
Right.
we are going to be doing some special Slooh missions using the Tilly telescopes tomorrow. So members are going to be able to see that on live telescope pages. But now listen, Paige, this thing, you said it's been was discovered 7.5 years ago, and then recovered. Are we going to see this particular object again? I mean, presumably it's orbiting what? It's orbiting the sun. In fact, we could take another look at that orbit diagram, and it might help explain what's going on here.
Yep. So it will approach again in October of 2019, October 17th. It
Oh, so
will make another close approach, but that will be over 111 lunar distances away. So it's going to be pretty far. So it's close, but it's not really, really close. Then in 2200, so a very long time from now, it will come about as close as it is now,
okay, so we're
or
safe
tomorrow.
for
Yeah.
we're safe for a short while. Well, probably not in my
Yeah.
lifetime, but who knows? With medical science, you might make it to 20, 2000. Who knows?
So the reason this is happening, if you're looking at this orbit diagram, you can see in white is the asteroid, and so its orbit around Earth is elliptical. So the orbit of Earth around the sun is elliptical, and then the orbit around this asteroid is also elliptical. And so depending on where the Earth is in the orbit around the sun, and then as the asteroid is orbiting, sometimes they're going to be really close together, and other times they're going to be further apart. So we're watching the close approach right now where the white and blue dots are essentially coming close to one another. But then you can imagine at moving at different speeds that the Earth is going to pull away. And so this is why it's not like a constant timing that we'll be able to see it. But
So they're
this
not
is actually,
orbiting the sun at the same rate. So
no,
it's quite rare for them to kind of
right,
meet up like this. But
right,
that's cool.
right. Yeah. And this is actually the 32nd known near Earth asteroid to fly by within this one lunar distance since the start of 2018. So even though this is
Wow.
close, and anything that comes close like this would have the potential to be really devastating if it were to impact. This does actually happen quite frequently. So what's rare about this is the size of the object and the speed
Yeah.
that it's moving for being in between us and the moon. It's a really rare occurrence for an asteroid of this size to come between us and the moon. But it does
Uh,
happen pretty frequently that an asteroid comes this close.
and size really matters in this particular case. And
Yeah,
size and velocity is mass and velocity, isn't it?
right.
That's the thing that, if it were to impact Earth, that's the thing that makes a very, very big difference as to how much damage it can do. So, this is a sizable object, and it's, I always say a stone's throw away in celestial terms, isn't it?
Right. Right. It's very close. I mean, the most common unit of measurement I would say that people are familiar with for astronomical terms, because of course, when we talk about astronomy units, we don't really go into miles and kilometers so much because it's just such large numbers. How do you,
Yeah,
wrap your head around that? We use the AU, the astronomical unit, which is one Earth sun distance. But when that's a really common one that people tend to be familiar with, but when something comes this close, we don't even talk about it in AU because it's so close. We go to this lunar distance and just say that it's half a lunar distance.
okay.
It
And it's
seems to
still pretty
resonate
cool
better.
in it is still pretty
Yep.
cool in miles, isn't it? 128,000 miles or something like that. But we're
Yeah,
still
yeah.
looking at it. And I don't know if viewers need to be really kind of focusing in on the images from one particular telescope. And don't forget, if you're watching at slooh.com, you can be flicking yourself between all of these
Hmm.
different telescope views and snapping your own images. So what we can do here is make sure when you see that little dot, that little line, is to wait for that next image to be streamed through and note where it is in relation to the background stars. And we can already see that this one has moved an incredible distance just in the 25 minutes that we've been on air. So hopefully viewers are able to see it in the mighty half-meter telescope view as well. So,
All right, Paul. Well, you are going to go check on social and slooh.com to see if
yes.
we have any questions from our viewers, right? And in the meantime, I have some exciting news that I'm going to share with everybody while we wait for more of these segments to come in of the asteroid.
Okay, I'll see you later.
All right. Okay, everybody. Well, we're going to keep our feeds up and we're going to keep chatting about what's going on with the asteroid when Paul comes back in a little bit. But in the meantime, I want to tell you a little teaser about a new project that we're working on. So, we're going to leave the feeds up, keep monitoring. You'll see this line increasing the more exposures that we get and watching the asteroid move. But I'm going to give you just a little bit of background on what we've been working at behind the scenes here at Slooh. So we have a thriving community of astronomers that use our telescopes in the Canary Islands and Chile every night, doing incredible things like watching tonight's asteroid flyby, or just the other day, Slooh member Emmanuel Conseil just discovered two more supernovae. The other night, we had Paul Cox online, and we were watching the shadow of the Jovian moon Ganymede on Jupiter. So Ganymede was making a shadow on Jupiter. But one thing we've learned over the years is that Slooh can be a bit of an acquired taste. It has a barrier to entry. We know that it's far easier to love Slooh if you come in with some pre exposure to astronomy, some knowledge, some experience, and then you can really appreciate everything that you're seeing through the telescopes, as well as the engineering magic that goes on behind the scenes to bring these live feeds to you. But if you're new to astronomy, or if you've never spent a long cold night perched outside somewhere with a telescope, it might be hard to fully understand everything that's going on in its current iteration in the way that we present our feeds. In June of last year, Slooh applied for a grant from the National Science Foundation to support our mission of teaching the world to explore space. And you might remember we were thrilled to learn in January that we won the grant. So during this time, we've been thinking hard about all the little things that make us excited about astronomy when we first set out on this journey, and all the things that have excited our members during this time over the years. And the sorts of things we see when we're presenting to a classroom full of students and children, and what puts the twinkle in their eyes. We want you to all to be like those children, learning to see something for the first time and being excited by it the way we are. Because we know that astronomy is hardly taught in school. And so, like the rest of us, you probably never learned much about it unless you went on to pursue it later in life. As we stated in our NSF grant proposal, I quote, "With the emergence of the new space age, there is a newfound interest in the exploration of space, not seen since we landed a human on the moon. Yet in the decades since, astronomy has been all but removed from the curriculum, despite fundamental human interest to understand our place in the cosmos." It's something I always think about since I did choose to go into physics and astronomy in my higher education. is that, we focus so much on biology and chemistry, and those are amazing sciences, and really great research comes out of them. And a lot of times people go into physics and study things in labs and particles on Earth and forces in motion, and we all but neglect that astronomy is a huge part of these sciences, and it branches all three, really: chemistry, physics, and biology. Astronomers are all of them, all of the above, or they have niches in each of those particular areas. So we're building a latest version for you so that you can learn how to appreciate all of the magic that goes on here, all on your own in a self-guided learning experience way, and with our full support, of course, as well as the support of this global community who want to help everyone else share in the incredible sights that they see. It's a big thing to build. Space is rather vast, but we're carving it up. We're getting ready to serve it to you in digestible pieces so that you can jump into the driver's seat and take control of the telescopes on your own, pointing them at whatever you want to look at, understanding what you're looking at, and sharing it with the world. It's one thing for me to sit here on a night like this and show you this asteroid and explain all about it while we're looking at it together. And we know people find that interesting because we've had millions of people tuning into these shows over the years, and we're really, really pleased that you do. But it's another thing for you to be able to do this on your own, setting up these missions by yourself, watching it by yourself, and then actually not being by yourself, but actually sharing it with the whole global community that's doing it at the same time without needing our guidance to do so. We want you to be able to point the telescopes at this little tiny block of rock that's moving at nearly 30,000 miles per hour from over 100,000 miles away, and know that not only have you captured it, you've actually seen it in your field of view, and you can do all of the fun image processing that comes after, and you have an appreciation and understanding of it for yourself. So this is our mission. We know that you can do it because we have tens of thousands of people doing it all the time with us. But now we want you in particular. I'm talking to you and you and you, and we want you to be able to do it. And in order for that to happen, we need to show you how. We'll show you our series of steps which you can follow, easy, engaging, that a middle school student can do it. And once you do it, we know that you'll feel it was worth it. It offers a whole nother perspective about this natural world around you, altering your sense of time and your scale of distance as you understand just how far away these objects really are. It's not enough for you to watch me doing it or Paul Cox doing it. We want you to do it. And that's what the new version of Slooh is designed to do, to train your eye like mine so that you won't need me anymore. But I'll still be here. Don't worry. Don't leave me alone on all of my live casts. We are questifying. I think I made that word up, but I like it. I'm going to go with it. Questifying space exploration, sending you on your journey into space to explore the vast cosmos for yourself. So that is my teaser for this new Slooh that's coming really, really soon. But so soon, in fact, that we don't have an exact date to put on it yet. But we will. We'll share that with all of you when we do. And you'll know about it. And we will all explore space together. So we are going to continue watching these live feeds. We're going to bring Paul Cox back so we can talk about impacts of these asteroids and how potentially dangerous they are to Earth, these near-Earth asteroids, and answer any viewer questions that Paul might have found while he got his little break. So let's bring Paul Cox back online.
Questifying, Paige, I like it. And by the way, however easy we make Slooh and however engaging we make Slooh, we could never do without you. So please don't go anywhere. Now, listen, let's take a look. Let's take a quick look, Paige. We have got some questions. Lots of people are saying hi from different places, so let us know on Facebook where you're all watching from as well. But here we go. This is one of the primary feeds that we've been looking at. So this is our telescope called the Canary 4 Solar System Telescope. Now, if you missed the beginning of the show, Slooh's flagship observatory is in the Canary Islands, which is about 300 miles off the west coast of Africa. And it's great because it means that actually it's dark. Darkness falls and the telescopes come online when it's still daylight in North and South America. But this one is optimized to look at planets and small objects like planetary nebulae and small globular clusters and stuff. But look at this, it's absolutely perfect to also look at a tiny object like this, a tiny fast object like this. And we've been watching it. That little line is what we're seeing. That is the asteroid. And actually, I've got a question for Paige about the brightness and how we know the size of these things as well. But let's flick through the other telescope feeds that we've got, because I want to point out this tiny little asteroid in all of these images. I still think it's absolutely amazing that we can capture this object, which is, albeit 400 or 500 feet in diameter, about 120 meters in diameter, but we can capture it when it's over 128,000 miles away. Now then, looking at this one, um, just right and below center in this particular image, this is from our premium telescope, the half-meter telescope. And anybody who knows anything about telescopes knows that that's enormous by any standard. You can see we've got these crystal points of stars over the entire image, but just right and below center, we can see one tiny little line, and that is this Near-Earth Asteroid 2010 WC9 as it moves during a 60-second exposure. And then Slooh's patented technology gathers up all of this imagery from the scientific grade CCD cameras and streams it over the internet to our service and straight to your laptop or desktop or whatever it is you use now. What are we saying here? Can't quite sit in here. So this is our wide field. I still think this is yet to appear at the north. It hasn't come into the frame because I think we're a bit truncated on that view. Ultra wide field, this is the one that I said you might need to snap your own images if you're looking at Slooh. Now, one of those, this is such a wide field of view, this particular telescope, that it is a little line, but that line is so short because we're seeing so much sky. It's actually quite difficult to pick out. But I bet you if you snap two of those images and compare them, you will spot that there is one moving object between the two images. So, and there we are with the Deep Sky telescope as well, and that's the same thing. It is there, but you'll need to snap it and probably look at that at high resolution. You might be able to see this if you're watching this show on your full screen. I've only got a little screen share of it on my screen, so I can't really see the detail, but there we are, we're zoomed right in again on that solar system telescope, and it's those two little white lines, so that's where we've combined two of our long exposures to capture this 120 meter. This is kind of football stadium size, isn't it, Paige?
Yeah, the size of the Statue of Liberty too, I think.
Yeah, yes, I saw that. I saw that reported. Now, we have got a couple of questions here. Now, Angie Thompson, she's asked if she goes outside, Paige, and look up, will she be able to see this asteroid?
No, unfortunately not. You won't be able to see it. It is not going to be bright enough to see with the naked eye. You would need a telescope for those telescopes, which we're providing to help with that. But no, you would need a telescope to magnify it for you.
Yep. So unfortunately, you can't even see this one through binoculars. It's not that bright. And actually, Paige, what I was going to ask you was, we've got a size here. A size estimate of something like 53 meters to 120 meters, which is something like 250 feet to 500 feet, something like that. But all we can see, even through the most powerful telescopes like this, is a small dot, basically, or a small line. So how do astronomers determine that size estimate when all they can see is a small dot of light?
So we do a lot of tricky math handling that basically we know the speed that it's moving and we have the apparent brightness of the object. And so we can determine its distance. And then all that information together is really what is able to give us the size. Knowing the apparent brightness of an object and the distance away from Earth gives us the size of the object. So we basically take some of the characteristics of an object that we see. We do this with other things too, like measuring the size of exoplanets around other stars, where we watch their motion through space, and their motion is what gives us enough information to be able to plug it into equations and calculate out things like size and absolute brightness and so on and so forth.
And there's a big assumption in there as well that we make, and that is what's called its albedo, an object's albedo, which is basically how much light it reflects. Now, a lot of objects, we kind of think that they're really reflective, like our moon, but actually the moon's kind of as reflective as coal. And so is this object too. And what happens is when these objects get so close, they fall within the range of very special types of telescopes, radio telescopes. And that's when we can actually do some radar imaging of these objects and
Hmm.
fix its size quite well. Who can
Right.
forget the spooky asteroid, where we were covering that live and we had the first radar images come in of that particular asteroid, and it was a skull shape. Oh, look at this one. That's a good one, Paige. Now, that's not the asteroid. The asteroid is the small line on the left-hand side. This is another artificial satellite. It's basically yeah, it's basically hogging our photo, crashing our photo stream. And there we can see it actually in the deep sky telescope as well. So this is very bright satellite actually that's whizzed through the field. But I've got another question for you here, Paige. Meridian Prime. If only that was a real name, wouldn't that be cool? Meridian Prime is asking, what part of the world is it optimal to watch this outside, north or southern hemisphere? Well, that's really cool.
Well, I mean, again, you can't see it unless you have a telescope.
A telescope.
But for tonight, you'll want to watch it in the northern hemisphere, and then tomorrow night, you'll want to watch it in the southern hemisphere. So both hemispheres get the opportunity.
Yeah, this is really cool, this image. Although it's not the asteroid, it's really cool because we can see here, this is where a satellite has whizzed through our long exposure. And we can see there's a very bright patch in their Page. And that's probably where it's got some solar panels that just happen to reflect more light, because a lot of satellites, they rotate, they spin to remain stable. So sometimes they kind of flash away at you. And that's what we're seeing in all of our images here. So there's always something unexpected up there, isn't there? Now, there was one other question, but it's not really a question, actually. It's more an observation. Angie Brown says, never seen this kind of thing. What's this about? The lost asteroid. This is kind of cool. So if anybody has joined the show late, Paige, why is this the surprise return of asteroid 2010 WC9? Can you remind us?
Because it was lost. So
It was,
back in
oh,
2010, year 2010, on November 30th, it was discovered for the first time. They monitored it for about, I don't even think it was a full month. It was
it
into
was 10, it was
December, that
10 days. Yeah, it was
10
only
days,
10 days. Yeah.
and then lost it. So these things, they're not that bright. This was what we were talking about with the reflectivity, the albedo of them. And so we can only see them based on how much light they're reflecting back at us, and how far away they are is how faint they're going to be. So the further away that they move, the fainter they become, and we lose them. And after only monitoring it for 10 days, calculating its orbital period for many, many years is really difficult. We really need to be monitoring it for longer. And so then when it comes back closer, we're able to recover the asteroid, is what they call it when they find it again. And then being able to monitor it for a longer period of time, now we can really constrain its orbital motion, and we know when it'll make a return. But recovering an asteroid or a comet, that's where the surprise comes from after losing it.
Yeah, and you know, I said at the top of the show, you know, some of these major programs like the Catalina Sky Survey, the survey that discovered this particular asteroid, and a whole number of other surveys cost millions and millions of dollars. So it costs millions of dollars to be discovering these asteroids, which do pose a risk to Earth. But the big problem is, after they're discovered, there's not enough people around the globe who are tracking that object afterwards to keep an eye on it so that we can more accurately determine its orbit so they don't get lost like this one. And that's really what one of the groups at Slooh does, isn't it, Paige?
Yes. And actually, there's a couple questions for you on Facebook. I'll give one that might lead into talking about these NAA tracking and what our group
Hmm.
does. The question is from Amber. Oh, sorry, it just started to move. Amber Leigh Stradley Peralta. How do they know it is asteroid WC9 and not a new one?
Okay, well, we know because over this, since it was rediscovered on the 8th of May, so we've got 6 or 7 days or something, there have been, I think I had a look, there have been 250 observations of this particular asteroid, including some by Slooh members. And what they've done is they've taken images of the night sky where the object should be. And what they do is they then perform a little bit of astronomy measurement, which is called astrometry, which is measure where the little dot is in comparison to all the background stars. And as we can see here, it's got a direction. So if you start stringing a few of these points together, you can very accurately determine where it's going, the direction and the speed that it's going, which is what Paige was saying earlier, which helps us define its orbit. And that's what Slooh members have been doing. So they make those measurements, they then submit them to a place called the Minor Planet Center. And they're the kind of clearinghouse for measurements from all around the world, including the Catalina Sky Survey, but Slooh members also make their submissions, and they do lots of math with it at that end, and they accurately determine its orbit. And that's what I then used to program the telescopes tonight to say, go to these particular coordinates, and we know that the object that we're seeing there matches up very clearly. And also, because of the length of the line as it moves through, say, a 60-second exposure, we can determine from that its speed. And we know that this matches the apparent speed that we should be seeing in Asteroid 2010, WC9 tonight. That line is going to be a lot longer tomorrow night when it's closer to Earth and the line is even longer.
Gotcha. That makes a lot of sense. And so for people wondering why we're saying it's going to be so much closer tomorrow night, so the closest approach, this is going to be about 126-ish thousand miles away. But tonight, it's over 600,000 miles away still, about 645,000.
Yeah,
So
yeah.
that's what we mean by closest approach. This really is still pretty far away.
But one of the things that was quite interesting today, Paige, when I was actually monitoring where this thing's going, so it's in the constellation of Hercules tonight, and I suspect that even if we compared our images from the beginning of the night to even now, we would see that the line that it's drawing, in other words, the distance that it's covered during any period of time of our exposures, has already increased. And after tonight, in fact, throughout tonight, it is getting faster and faster and faster. And that's because of that explanation you gave about a car traveling 70 miles an hour,
Right.
miles away versus a car traveling 70 miles an hour right close to you. When it's closer, its apparent motion looks a lot faster. And this thing is whizzing, heading south at an incredible rate of knots. You look at it in a planetarium software, which shows you kind of virtual sky, and you can see it hopping through a whole bundle of constellations until it's heading, as I say, very close actually to the southern celestial pole. And that's why tomorrow night, at closest approach, you can only see it if you're at a southern latitude. And our Chile observatory is absolutely ideally placed to see it tomorrow. Hopefully the weather's going to be clear as well, Paige.
Fingers crossed. There is a couple questions floating around Facebook that are all pretty similar, asking about the lines. And you just explained that they're going to get longer.
Mm.
And also a little bit, people are asking kind of why the lines appear to be like wobbling as they, like start to
Yeah.
dot our screen.
Yeah, so some people interpret that the asteroid is tumbling or anything like that. It's not. This asteroid is going so fast, it's on such a perfect line, that it's not wobbling at all. But what we see is this is the tiny movements over the course of each exposure of the telescope tracking. Maybe the wind blows it a little bit. Maybe there's a high and a low in some of the gears and the mechanics. And that's actually what we're seeing. We're seeing basically a recording of the telescope wobbling slightly for a whole bunch of different reasons. So,
That's actually really cool to know. And I think that's when I was talking earlier about this new launch that we're doing with the project we're working on, and was saying, if you come in here and you don't have a ton of astronomy experience or observing experience, the engineering magic that goes on behind the scenes gets lost to you. And this is exactly what we're talking about. The engineering magic, the robotic telescope, they
yeah.
have components in there too that make these images do the things that they do.
Exactly. And when you actually understand, when you're sitting from the comfort of your own armchair watching live views in the telescope interfaces, on missions that you've set up, objects that you've controlled the telescope for, you're sitting there in the comfort of your own armchair. But actually, we think we need to share more of the magic that's going on at the observatory because it enhances the experience. Oh, look at that. This might be why we're seeing, some of the images getting a little bit noisy. So this is our low light special camera here looking at the entire sky. The very brightest spot there is Jupiter. Jupiter was at opposition last week, which means it's at its brightest right about now. But actually, the other things, Paige, you can see down there on the left-hand side, because it's a fisheye distorted lens, those are the telescopes and the domes inside the white dome. So that's quite cool to see that. But hopefully these clouds will clear away. But, we've had a good run so far. I've got another question for you, though, Paige. It's a pretty fundamental one, actually. It's from Graham G from the UK, who's asking, and we haven't really said this, what is a near-Earth asteroid? What's the definition of a near-Earth asteroid, which is what this is?
Okay, so a near-Earth asteroid, as opposed to a regular asteroid, a non-near-Earth asteroid, means that the asteroid comes with a perihelion distance less than 1.3 AU. So the perihelion is the closest distance that the object comes, so the closest approach. And so less than 1.3 AU. And I mentioned earlier that the AU is the distance between the Earth and the Sun. So less than a little bit more than that, essentially. And that's actually about 120 million miles.
Wow.
120 million miles is about, if it comes closer than that, it is a near-Earth asteroid.
Okay, and there's another designation as well, which we won't go into now because this object isn't, but if they're a certain size and can get even closer to Earth, then they're also classified as a potentially hazardous asteroid as well. But,
and I think that also has to do with the crossing of the orbit.
Yeah. So, Paige, we're talking about this, and we're talking about this being a near-Earth asteroid, and we're talking about maybe some of the risks. And some people, after some of the shows that we've done over the years about near-Earth asteroids and close approaches whizzing by, they've kind of said, "Oh, it's a load of hype," but it's not, is it? It's not unknown for celestial objects to collide.
Right. Definitely not. I mean, the dinosaurs, right?
Yeah. So that's the Chicxulub crater. So this is 65, 66 million years ago or something. And we reckon that one was a comet around, about 9 miles or something in diameter, slamming into the Earth. And of course, an object that big will always make it through Earth's atmosphere, so it will always impact. And, it's widely accepted that it kind of killed off 75% of plant life and animal life and everything except, I think, the non-avian dinosaurs. All of them went except the little feathered ones. And the crater, I think, is something like 93 miles deep. It's under the sea, but it's a really well-studied place. But we've also got these more up-to-date examples as well. And one of them, actually, that we can talk about was the precursor to Slooh members in our Near-Earth Asteroid training program starting off. But of course, we had in Russia, didn't we, the Chelyabinsk meteor. It's taken me since 2013 to be able to say that word properly, Paige. But there we've got an object which is even smaller than even the lower estimate of the size of this particular asteroid. So we reckon it was about 17 meters in diameter, about 10,000 tons. And that exploded over Russia on the 15th of February 2013. Actually, a few hours before we were going on air about another near-Earth asteroid that was passing that particular night. But that wasn't the first time Russia's been hit in a lifetime. There's also this great event from 1908, which is called the Tunguska event. And this one wasn't really witnessed by anyone. A few people heard it, but they reckon this was about 1,000 times more powerful than the atomic bomb. And this particular object, they think it exploded in the sky and caused an airburst over Siberia. And it flattened something like 80 million trees over this area of something like 5,000 square kilometers. And I don't know if you've seen pictures of this, but all of the trees are just flattened like matchsticks. It's the most extraordinary sight. But that was 1908. But then the one that I remember, you're too young to remember this one, Paige. Oh, actually, you might be. You might be in toddler. Shoemaker-Levy 9. This was the first time we made direct observations of an extraterrestrial collision of solar system objects. And this is an almighty comet Shoemaker-Levy 9, which actually was also the first comet that we'd ever discovered which orbited a planet, and it was orbiting Jupiter, and it broke up into 22 pieces because of Jupiter's gravity, which is what it's, you take Jupiter and it's kind of twice the size of all of the other planets in the solar system put together. So first of all, it was ripped apart in 1992 by Jupiter's gravity, but then in 1994, we witnessed them one after another. So this whole string of pearls, 22 fragments of comet, we watched them pummel Jupiter as Jupiter was spinning around, and it left these huge pot marks, these huge black marks, which were larger than the size of the Earth in Jupiter's clouds, which could be seen for weeks afterwards. So I mean, that was I can remember watching that on the news and seeing those particular images, Paige. That was a really cool event.
That's actually a theory for how some of the rings form around planets is something pummels into the planet and shoots off debris back out into space, and then it stays in orbit, because it's so light and so close, and that can form a debris ring. Fun fact.
Actually, while we're on this, we've only got a few more minutes left, but before we finish off, there was one other great example of an asteroid impacting Earth, and it was in 2008. And this was the first time that an asteroid impact had been predicted prior to it entering the Earth's atmosphere. And this particular object was called 2008 TC3. It too was discovered by the Catalina Sky Survey. But the big important thing with this one, Paige, it exploded over the Nubian Desert in Sudan. But Slooh members were among only 3 groups of people who managed to capture 2008 TC3 as it was flying in over the atmosphere just hours before it impacted Earth. And it was that one moment that got so many of us at Slooh, so many Slooh members at Slooh going, whoa! Before that, we hadn't really ever considered that asteroids do impact Earth. So this is not tabloid scare tactics. This stuff happens all the time. And very recently as well, we've witnessed more impacts on Jupiter. We've witnessed and videoed, amateurs have videoed asteroids impacting the Earth in these mighty, flashes. But anyway, Paige, we've got a couple of minutes left. Have we got any final questions we can deal with at all?
I don't see any. But to go back to that question earlier about why this is called a surprise asteroid, that's something that kind of goes along with these impacts is, they don't necessarily happen super often, and we don't have to, every time the tabloids say there's an asteroid coming, we don't always have to worry about impact. But when we lose these asteroids and comets, that's how we get these impacts, because we don't know where they are. That's the problem.
Exactly. So
there's a question on Twitter. Oh, this is a fun question. Does calibration data come with the raw data so that these images can be reduced to be scientifically valid for astrometry and photometry? Paul, that is a question for you.
And it'll have to be a really quick answer because we are running out of time. Yes, all Slooh data for astronomer members, you get the FITS data, what's called the scientific FITS data, comes fully calibrated. Now, Paige, we have got to wrap up our live coverage of Near-Earth Asteroids. We're still watching these live images of it. Now, Slooh members, you're going to get to see these continue at slooh.com on the telescope pages. So, carry on enjoying that. And we'll also have some special missions tomorrow night from Chile. Paige, we've always got loads going on here. I'm back on Sunday for my next episode of Practical Astronomy. So if there are any new members who are joining tonight, one of the things that we'll deal with there are all the basics of using Slooh. And you can see just how easy it is to control mighty telescopes halfway around the world on top of an 8,000-foot volcano. So, Paige, I think that probably winds it up for us. I'm Paul Cox with Dr. Paige Godfrey, and this has been another astronomical sleuth production. We'll see you soon. Good night.
Good night.